Hi, welcome. Today we're working on square roots. So the square root operator, which is just this little symbol, right? It looks like the bus stop method for division with kind of a little check mark on the left-hand side. Okay, it's the reversed operation to squaring something. So whereas squaring something made it bigger, so 2 squared was 4, square rooting a function or square rooting a number such as 2 squared means the square root of 4 means we get back our base number. So that is what we end up getting. Right? We get back our base number. So the square root, if it has a power of 2, we'll just get back our base number. Okay? So just like it's opposite, adding is opposite to subtracting, and multiplying and dividing come in pairs, right? So what does this look like? Well, if you look at the below there, we have this square root of a squared. We can break that up into square root of a times a, which is simply a, when a is greater than 0. Similarly, if the square root of 4 squared is the square root of 4 times 4, which is the square root of 16, and opposite to, if we take 4 squared, we'd get 16. Opposite of that, we get plus back 4. So one thing to point out, that in terms of what number can go under a square root, we can only get positive numbers, okay? We can only get use positive numbers. That's the reason why is really deep and detailed. It just has to do something with having real and imaginary numbers, and the real numbers are where they're positive and imaginaries are negative. But that is not in the term of normal high school maths. So, but if you wish to go further into it, it is quite an interesting topic. Anyways, back on task. Example 1. What number multiplied by itself results in 25? So if you're starting out this process, well, we can just think of all the numbers that make up 25. We have 1, 5, and 25. Well, 1 times 1 isn't going to be 25. 25 times 25 won't be 25. Well, 5 times 5 is. So we have 5 times 5 is 25. Right? So we can say the number 5. So here we're starting with our 25 and working back to get our 5. When we did, so roots go that way. When we did our powers, or our indexes, right? Our powers went from small number to big number. Okay. So here, what is the square root of 64? So here, this is what the square root of 64 looks like. Okay, so we're looking for this. We're looking for what number times itself makes 64. Well, if we go back and we think of our perfect squares and all that stuff we did before with our squares, we can do 1 times 1 was 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, then 25, 49, and then 64. And we find that is 8, right? So that's because this is our perfect squares, right? When they work out to these integer numbers. So here, right? Because we know we can represent 64 as 8 squared, and a square root is the opposite to squaring something, so we get back just our inside number. Similarly, on your calculator, you could look for this, and it is the one that does not have a number or anything right here. It's just your normal one, and you could put in the number 64, and you would get out the number 8. Knowing your square roots is pretty handy for your perfect squares up to 15, just because you'll use them a lot. And if you actually start to memorize just the forward process, the backwards process is just like how we do multiplication and know our times tables really well. But going backwards to do division, we don't really do division. We actually just do multiplication. And we think about, oh, well, what did I have to do? I have my 2 factors. It had to be one of those numbers. So, consider the following area, 36 centimeters squared. What is the side length? Right? So if it's a square, we know that these 2 sides have to be the same, right? So we can label side A and A, just as before. And so our area is equal to A squared. So if we want A, how do we get just back the little a, right? Not our area. Well, we take the square root. And I'm just going to do that in red, because keep in mind when we've been solving, if we do the one operation to one side, we have to do the same operation to the other side. So on the right side, we get our a value, and that's actually a plus or minus a value, but we don't really worry because we just want the positive number. Over here, square root, and what's our a? Well, that's 36. So what two numbers multiply together? 6. Some of you might say, I just knew that it was 6 right away. I didn't have to do the square root. That's completely fine. This is just some applications, easy applications of why we need to know square roots. So if we know that we have 6 centimeters for our side length, right? Then perimeter, well, the perimeter for a square is just 4a, right? It's a plus a plus a plus a. So that means we have 24. Because we have 4 times by our 6 centimeters, which is 24 centimeters. So, knowing that, I want you to see how far you can get through this without a calculator. Okay? So, thinking that, okay, that number underneath my square root, I'm looking for what number times itself will give me that. That'll be your answer. Okay? So, what number times itself will be 4? Is it 1 times 1? Well, that's 1. How about 2 times 2? Well, that's 4. So, therefore, that is 2. Similarly, we can keep going on. I want you to try. If you get stuck, then go to a calculator and make sure you can check your answers. And then we'll take up the problems after you press play. Alright, so what number times itself makes 25? Well, that's 5. We've done that. The only number times itself that gives 1 is 1 times 1. Well, we know that 8 times 8 was 64, so it's a little bit bigger. 9 times 9 is 81, so our answer here is 9. Well, this one's a little bit harder, but if you know your times tables, 12 times 12 is 144, so let's go bigger. 13 times 13, that's 169 for sure. Ooh, square root of 12. Well, this one we can't really just do, right? But here's one thing, right? We can break up this as 4 times 3, right? And the square root of 4 is 2. And then we have this root 3. That doesn't really help us, though. But I just wanted to show you a little way of you can simplify. However, you can put that in your calculator either, so 2 root 3 or just the square root of 12, and you'll get 3.46. I always just keep it to 2 decimal places. Square root of 45, once again, you can't really do that, so square root of 45 is 6.71. And you see where you actually need a calculator with some of these, right? I will show you a method at some point when we do estimating that works out very well with, I'd say, 0.01 degree of accuracy. So, if the area of a square is 50 centimeters squared, what is the perimeter? Well, our area is 50 centimeters squared. So, that's a square, so that's equal to our a squared. So we know we really just have to take the square root of both. So the square root of 50 is equal to a side, and we know that our perimeter is equal to 4a, or side plus side plus side plus side, right? And so we get 4 root 50, or if you just wanted to put it in your calculator before and do 4 times by root 50, or root 50 plus root 50 plus root 50 plus root 50. Any way that you go about doing your maths there, you get 28.28. Lastly, how are we going to simplify this, right? Well, we know that we can write this. How about if we write this x squared, right? And then we say inside we say it's times by x squared. Because we know that the square root, then we could write this as the square root of x squared times by the square root of x squared. We haven't changed that at all. And then that's just x times by x. So in the end we get x squared. So it looks like whatever power we have on something that's inside of a square root, it just seems to have it, right? Because 4 to 2, that was just half. I wonder if that seems like a law that we'll go through eventually.